Okay, we are recording. So, Shofshiznale, this is being recorded, um, and it will be shared. So, anything you say will be held for you or against you. Okay, mi ekran. Da. Okay. Okay. Чи хтось то не бачить? Окей. Я тільки попрошу, щоб всі засили мікрофони, якщо ви можете. Окей. Перед тим, що ми почнемо, я хотів таки скоро вам дати знати про Perseverance, що полетів на Марс пару днів тому. So це є фотографія, it's from the orbiter довкола Марсу. Той маленький білий спек там посередині, то власне, то справді є the parachute and the orbiter as it's approaching the surface. Okay? І то є правдива знімка. За ким Perseverance доторкав землю Марса. А тоді, just after that, тут є знімка, і то є правдива знімка. The rover itself was supported on wires. І пустили під the lander or the spacecraft as it was coming down, which used jets to slow itself down. Не тільки парашут, але і також ракети. Пустив так Perseverance до землі. Це не є знімка. This is a computer-generated image, як він виглядає. І то спереду, то є гелікоптер, що вони збудували. То буде перший гелікоптер на Марсі чи на іншому планеті. And that's to scale. Можливо, що ви бачили таку знімку. По інтернеті воно полетіло. То має бути з Марсу, то має бути 3 планети: Венера, Земська куля і Юпітер. На жаль, this is a fake. То не є правдива знімка. This was... I even got fooled by this. То виглядало, що it came from PBS. То неправда. Snopes has debunked it. So, якщо ви то побачите, не вірте, то не є знімка, як виглядає наша планета з Марсу, на жаль. Окей, але правдива знімка from Perseverance так виглядає. То є Perseverance на Землі, Марса. Now, чому це є важне? То не є тільки ще одна ракета, що полетіла на Марс. Perseverance має дуже складні інструменти, специфічно, щоб шукати за сигналами життя на Марсі. So, вони вже знайшли, що ми знаємо, що давно тому була вода, плин, liquid water на Марсі. Ми знаємо, що там є all the chemical signatures of life, the schnapps, вони так називають, carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur, вони всі є на Марсі. So the ingredients are there. Тепер питання є, can we find any direct evidence of microbial life? І Perseverance має всі ті інструменти, щоб то знайти. Я вже дивився на 2 documentaries, чи 2 news programs. Цей, що я вам тепер пускаю, this Looking for Life on Mars, it's a Nova special, то є на 1 годину, то переходить, як вони будували perseverance, як вони стріляли ту ракету, the incredibly risky and uh, amazing engineering, як воно полетіло на Марс, і як воно там сиділо. It's fabulous. It's riveting. То є знаменита річ. So Google Nova, looking for life on Mars, і ви то знайдете. А також there's a news program на 10 хвилин, дуже гарне. If you Google 10 images that reveal what we've learned on Mars, it's on YouTube. Google that, і ви то знайдете. Знаєте що, I can put this into the, я тут дам in the chat, щоб всі мали these links. Я то зроблю, заки ми скінчимо. Okay? So, то є тільки public service announcement щодо, що ми тепер робимо на Марсі, і за пару місяців, може за пару років будемо знати, чи колись там було життя на Марсі. Окей. Relativity, відносності. Це є дійсно дуже складна тема. Okay? Деякі частини того є тяжко вірити, тяжко розуміти і тяжко вияснити. Мій план є, що ця гутірка буде менш-більш по-українськи і по-англійськи. Okay? Бо моя ціль є, щоб всі зрозуміли ті теми, and the explanations can get very detailed and very specific. So, то буде частина по-українськи, частина по-англійськи, тільки щоб ви то знали. Now, relativity, то приходить в двох частинах. Special relativity came first, historically. So, Einstein, і так маючи вимовити його ім'я, він був німець, чи з Німеччини він був, по-німецьки його прізвище є Einstein. Special relativity, він то написав, he published it in 1905. So 115 років тому ми вже то знали. Now, special relativity, то що має до діла з швидкістю. So what happens as you go faster and faster? Relativity applies at all speeds, okay? Even slow speeds. Але тим скорше ти їдеш, тим більше той ефект. It really doesn't matter until you come close to the speed of light. You can measure it at slower speeds. It's there, but it doesn't really have much of an impact. І ми то перейдемо. Okay? Але тим ближче, що щось летить до швидкістю світла, тим більше то важне. Але, так як я сказав, то існує навіть як ти поволі ходиш чи їдеш. Okay? And найважніше, it impacts every one of us every single day. Я то вияснив також. And you can use it to travel through time. Now, general relativity. General relativity, також Einstein то видумав, it's general because it doesn't just apply, well, special relativity only applies if there isn't gravity and there isn't acceleration, just if there's speed. General relativity applies in all cases. So that's why it's general. Now, general relativity applies in a gravitational field. Тим ближче до планети, до зірки, тим важніше. Okay? The stronger the gravity, the bigger the effect of general relativity. It really is weak near us, even near the sun. It really only matters if you're near a very, very massive body, like a black hole. Talking special relativity matters only if you're going very fast. General relativity really only matters if you're near a very, very strong gravitational field. Ale, you can measure its effects even here on Earth. And it impacts every one of us every single day. And you can use it for time travel. Okay. Now, я тільки вам дам приклад, яке дивне це може бути. Okay? So, here's one of the effects. Ми перше перейдемо special relativity, тоді ми перейдемо general relativity. One of the effects. Нехай скажімо, що Галя і Ігор сидять на земській кулі. Okay? Але Галя, вона рішить піти в ракету. І та ракета їде дуже-дуже швидко. Okay? It's going fast, very fast compared to the speed of light. Okay? So, вона сидить в ракету, і вона полетить. Okay? She goes very close to the speed of light. Let's say 99.999% the speed of light. Дуже близько. So it's a big effect that it's going to have. Вона виходить з ракети, і вона іде шукати свого товариша Ігоря. And when she finds him, now let's say she was gone for 2 days, flying around at near the speed of light. She comes back, вона знайде Ігоря, але він вже є старий пан. Okay? That sounds like science fiction. It is not. One of the crazy effects of relativity is that time, the passage of time, is relative. Okay? Now, we're going to return to this, бо то дійсно є дуже дивне і складне, але я хочу перше трохи вияснити. Okay? So, перша річ, all speeds are relative. Ми це вже знаємо. There's nothing new about the concept of relative speed. Okay? The strange thing with relativity is what happens when you go near the speed of light. Now, what do I mean? Якраз тепер ми всі сидимо в наших хатах. Okay? І можна сказати, що ніхто з нас не рухається супроти іншого. Right? Our speed relative to each other is zero. Or my speed relative to my computer is zero. I'm not moving. You're not moving. Okay? Але то неправда. Бо ми знаємо, що земська куля крутиться. Right? We're rotating. It takes 24 hours to go all the way around. It's about 25,000 miles around. We are moving about 1,000 miles an hour around the planet as we twirl. Okay? So we're all moving. So we all have a speed of 0 compared to the room that we're in. We all have a speed of 1,000 miles an hour compared to the center of the earth. Але земська куля рухається. The whole earth is moving compared to the sun. Right? So now that is much faster. We are actually moving about 67,000 miles an hour as the earth goes around the sun in its orbit. You can check my math. We're 93 million miles from the sun. The circumference of the circle that we make in one orbit is 2 times pi times 93 million miles. That's how far we're going to travel in 1 year. It takes 365 days. So divide that number by 365. That's the speed in miles per day. Divide by 24, and you get the speed in miles per hour. It's 67,000. So you are moving at 0. You are moving at 1,000 miles an hour. You're moving at 67,000 miles an hour. And the whole point here is speed is relative. You measure a speed compared to something else, always. Okay? So mitzev вже знаємо. Right? This is not, як ми сидимо в літаках і ми дивимося, we look down on the ground, we look like we're moving pretty fast. Але часами там є інший літак недалеко від нас, і ми можемо його бачити. And it doesn't look like he's moving at all. We're both moving at 500 miles an hour compared to the ground, but it looks like he's just hovering out there. І ми так виглядаємо до нього. Right? If someone on that plane looks at us, we're not moving at all. So the concept of relative speed is nothing new. Now, цей приклад тут. I just want to show you that different people will measure different speeds for the exact same phenomenon. So, наприклад, маємо Галю, маємо Ігоря і маємо пані Лешу. Okay? Let's say що Галя і Ігор are both on a flatbed moving trolley. Чи то може бути a truck, it can be a train, it doesn't matter. They're just moving. Okay? Вони рухаються. They're moving to the right. Now, Igor is going to measure a speed of 0 for Галя. Він каже, що вона не рухається. Пані Леся каже, що і він, і вона рухаються, they're both moving at 2 kilometers an hour. Okay? Nothing special here. This is just the relative nature of speed. Нехай скажімо тоді, що Галя speeds up. Okay? Now, Igor says that she's moving at 2 kilometers per hour. Pani Lesha says she's moving at 4 because she's moving faster than Ihor. Ihor thinks she's moving at 2, but Pani Lesha thinks that Ihor is moving at 2. So everybody measures the speed relative to themselves. Okay? Nothing magical there. Now, нехай скажімо, що same situation, але Галя і Ihor не тільки are traveling on this trolley, but they also have baseballs, і вони будуть кидати ті м'ячі. They throw them ahead of themselves, and they move in the same direction. Now, Ihor says that Haya is not moving because they moved at the same speed. Okay, I'll do that again. They move at the same speed. Alevin kaže što Miach is moving even faster. Let's say 10 kilometers an hour. Pani Lesha says they're both moving at 2 kilometers an hour, and both of their balls are moving at 12 kilometers an hour. They just add up. The speeds just add. That's the important part. The speeds just add. Toseme over here. Now this time, Haya moved faster. Ihor moved a little bit slower. So he says that Haya now moves with a speed, and her ball moves 12 kilometers an hour. Pani Lesha says she's moving at 14 kilometers an hour, but he's moving, her ball is moving at 14, and Ihor is moving at 12. Okay? The point here is speeds add up. Imit says Nayamo. This is also nothing new. Now, Jako Plastune, this actually has practical application. Now, тому що я є морський пластун, мої приклади будуть на воді. Okay? Наприклад, нехай скажімо, що Галя є на вітрильнику, і Ігор сидить на бережі. Okay? Ігор бачить, що корабель, so this is according to Ігор, він бачить, що корабель пливе в одну сторону. І він бачить, що вітер пхає з другої сторони. So, to a person who's sitting on the plaja, the boat is moving in one direction, he can measure that, and he can measure the direction the wind is coming from. Для Галі на кораблі виглядає її, що вітер приходить from a different direction and has a different speed. She will measure a different speed for the wind and a different direction for the wind because speeds add. Наприклад, якщо ти є на ровері, нехай скажімо, що нема вітру, і ти сидиш на ровері. You're not moving yet. You put your hand up. There's no wind. Ти починаєш їздити. Okay? You're moving. Нехай скажімо, you're doing a good clip, 10, 15 miles an hour. Ти чуваєш той вітер. But if you stop, нема вітру. So you measure a speed for the wind relative to your own position. Okay? Якщо ти є на таборі, де є канойка, нехай скажімо, що Ігор сидить на бережі одної сторони ріки, а він хоче плисти до Галі. Okay? Ріка пливе. Якщо він би попробував поплисти через ту канойку просто до Галі, він, на жаль, її не би стрінув. Бо ріка його попхає downstream, і, again, relative to the ground, він би опинився дальше від Галі, чим він хотів. He has to take into consideration the speed of the water, again, because speeds add. Якщо він в той напрям би керував канойку, то він би опинився ближче до Галі. Okay, so speeds adding is the important thing here. Now, nothing about this so far is special. This is everybody knows this. This is easy stuff. The crazy part comes next. Okay? Світло так не працює. Okay? So Einstein мав таку дуже цікаву ідею. Він подумав і він сказав, what if light obeys different rules? The speed of light is always measured to be the same value, no matter how fast the observer is moving. Іншими словами, what if light doesn't obey this adding of speeds rule? Okay? Now, these are a bunch of equations. Einstein їх знав. These are the equations of light. They were discovered, може, 30 років перед тим, що Einstein почав про це думати. The important thing here is that these are equations that relate electric fields and magnetic fields. Є два числа. There's this число epsilon і число mu. These are constants in the universe. And якщо ти їх береш, multiply them, take the square root, you get the speed of light. Because light is electromagnetism. And these two numbers, this is the important part, this is where Einstein got his idea. Ті числа, they are constant in the universe. They don't change based on your speed. So he said, if the constants don't change based on your speed, then the speed of light can't change based on your speed. So the speed of light is special. It is always measured to be the same speed, no matter how fast you're going. Ми ще бачили багато прикладів, where if somebody's moving with one speed and throws something with another speed, you have to add the speeds to get the speed that you're going to measure for it. But light doesn't work that way. And that has crazy consequences. Now, the assumption is, okay, Yoha assumption, Einstein, what if the speed of light is always measured to be 3 times 10 to the 8th meters per second, 186,000 miles per hour? Even if you're moving at that speed, you will measure light to be moving at 186,000 miles an hour. That's really crazy. Okay? Наприклад, let's go back to Halia and Ihor and Padilesha. Nechai skажim, що Halia і Ihor, вони в аутах, and they are both moving, Padilesha says, they are both moving at the speed of light. Okay? So they're both zipping by at the speed of light. Now, Halia bache, okay? Halia bache, because she has to measure Ihor moving at the speed of light, Halia sees Ihor moving away from her at the speed of light. Panilesha sees both of them moving with the same speed, the speed of light. But Halia sees Ihor zipping away from her. If that's not crazy enough for you, what does Ihor see? Ihor sees Halia moving away from him at the speed of light. Because everything that moves at because the speed of light is always measured to be the same amount. That's the assumption. So if Einstein's right, these people would actually see different things. Halia bebachla što Ihor letit vidnei, Ihor bachla što Halia letit vidneho, and Panilesha sees them both moving at the same speed. Strange. It gets worse. They're going to turn their headlights on. Light should move away from them at the speed of light. But it depends on who you ask. If you ask Panilesha, вона сказала, що і Halia, і світло від її аута, і Ihor, і світло від його аута, all 4 of those things are moving at the same speed, the speed of light. Because if something's moving at the speed of light, you measure that speed for it, no matter how fast you're moving. So she measures all 4 of them moving at the speed of light. Halia sees the light leaving her car at the speed of light. She does not see light leaving Ihor's car because Ihor's car is traveling at the speed of light. So Halia sees her own beam of light and Ihor's car neck and neck, and the light coming out of his headlamps never comes out because it's moving at the same speed as his car. Ihor bache tosame about Halia. Now, причина, чому я це все вияснив, is because перед тим, що Einstein це все видумав, the idea was always that we would measure a relative speed, ale, vidal, y chas, those are the constants. Everybody's going to measure the same distance. Everyone's going to measure the same amount of time. And it's always the speed that becomes relative to how fast you are moving. Einstein said, no. When it comes to light, speed is the thing that everyone will agree on. Everyone will always agree on the same speed for light. And that means that they cannot agree on how the distance is measured, what kind of a distance you have, nor can you agree on how much time has passed. Time and distance become relative, speed becomes absolute. It completely flips everything on its head, and the equations then force us to accept some crazy consequences. So, so what are those crazy consequences? As you approach the speed of light. Okay? 3 very crazy things. Persharich, time slows down. Time itself slows down. It's some kind of a mirage or some kind of a mistake. Time itself slows down. Distances contract. Length contracts. The object that's moving gets squished, and the distance that it has to travel appears to be less. Okay? На жаль, mass increases. Значить, що є тяжче. It has more mass. Literally has more mass. Okay. Now, як це бувається? Well, there's a relatively simple equation. Okay? All three of them obey the same equation. I put it down, якщо хтось хоче це розуміти, it's 1 over the square root of 1 minus the relative velocity squared. So beta is how much of the speed of light you're traveling. So if beta is 0.5, you're moving at half the speed of light. If beta is 0.9, you're moving at 0.9 or 90% the speed of light. Now, щоб це розуміти, let's see how big of an effect this actually is. Okay, наприклад, якщо ти сидиш в ауті і ти їдеш 100 кілометрів на годину, okay, 60 miles an hour in a car, the effect of time dilation, now because you're moving, you will experience a slowing down of time. How much time will slow down for you? 4 nanoseconds less. You experience 4 fewer nanoseconds every 10 days compared to somebody standing. You can't measure that. Okay? It's there, but it's irrelevant. Trochę skorsze. Let's go to a jet plane. 1000 kilometers na hodinu. Okay? Now, the difference between the amount of time that you experience and people on the ground, 4 nanoseconds, you experience 4 fewer nanoseconds every 3 days. Still irrelevant. Okay. Rocket ship. This is escape velocity from Earth, 11,000 meters per second. Astronauts going up to the space shuttle, they experience 1 fewer nanosecond every second. Still irrelevant. GPS satellites, okay? Their speed is 39,000 meters per second. They experience about 10 nanoseconds less every second. To bude ważne. If you go at 10% the speed of light, the effect is 1/2 of 1%. Znaczycie 5 seconds less every 3 hours. So every 3 hours, you actually experience 5 fewer seconds than somebody who's standing still. At half the speed of light, the effect is 15%. At 90% the speed of light, the effect is now 2.3, meaning they experience twice as much time as you do. For every day that you experience, they experience more than 2 days. At 99% the speed of light, 1 day for you, if you're traveling at 99% the speed of light, 1 day passes for every week that passes on Earth. You experience a 7-fold decrease in the passage of time. Okay? At 99.99% the speed of light, it's a 70% effect. At 99.9996% the speed of light, 1 day passes for every year on Earth. So дійсно можна бачити, що дуже скоро треба їхати to get these effects in a time frame when we can experience it. Now, найшвидша річ на світі, на земській кулі, not in space, but the fastest thing on Earth are the protons in the Large Hadron Collider in Geneva, Switzerland, at the physics laboratory. They are moving at 99.999991% the speed of light. Dla nich, 1 day passes for every 20 years that is passing in the laboratory just a few feet away from them. Okay? Literally, time for them has slowed down by a factor of 7,500. Okay? I tym skorsze, що щось летить, the more time slows down. The implication is that for light itself, which is moving at the speed of light, time does not pass. There is no such thing as time at the speed of light. It has no meaning. Okay, let's go back to this приклад, що ми мали спочатку. Галя і Ігор, нехай скажімо, що вони обоє мають 20 років. Okay? Галя, астроном, вона знайшла планету, і вона хоче там поїхати і відвідати. Та планета, it's 10 light years away. Що то значить? That means that light takes 10 years to go one way. Okay? So добре 10 років, щоб світло там полетіло. Вона збудує ракету, дуже складну, важну і добру, сильну ракету. It can move at 99.999999% the speed of light. Так скоро as the protons in the Large Hadron Collider. Для неї, if she goes at that speed, for every 1 day that she experiences, 20 years will pass on Earth. Okay? She's moving almost at the speed of light, so то їй візьме 10 років полетіти до тої планети. Okay? let's start the clock. Time equals 0. Вона сидить в ракету, і вона летить. And she goes off to the planet. Now, she gets there. Їй здається, що то брало півдня. Чому? Well, because of the time delay contraction. Okay? At that speed, she will travel 10 light years in just half a day. Now, to her, it doesn't look like it's 10 light years away. Remember, distance also shrinks. So for her, it actually looks like the distance is much, much closer at that speed. Але для Ігоря Галя там прилетить 10 років пізніше. So Галя has experienced half a day. She's physically on the planet. Igor has experienced 10 years. He's actually experienced all of those 10 years. She has actually only experienced half a day. На другий день, вона змучена, she had a long trip. На другий день
Почекай, в мене є питання.
Прошу.
А коли вона, на half a day там прилітає, вона age або не age?
She ages by 1 half day.
Тому коли вона прилетить обратно через 20 літ, вона буде виглядати, як вона виглядала день назад.
Sorry, скажи то знову, бо я хочу докладно чути, як ти про це думаєш. Прошу повторити.
Ага. Так що, коли вона прилітає в землю, її...
Чекай, котру землю? Та планета чи назад на земську кулю?
Назад на землю.
Окей, дай мені хвилинку, бо цей приклад я переходжу, бо вона вертається незадовго. So, give me a second.
Ага.
Нехай я перейду чолий приклад і тоді запитай питання, окей?
Ага.
Окей, so far, вона там полетіла, окей? Дуже швидко. Ігор, він пережив 10 років, він є 10 років старший. Він тепер має 30 років. Галя тепер має 20 років і півдня. Okay? So вона має 20 років. Окей. На другий день для неї, okay? На другий день вона пустить сигнал назад на земську кулю. Вона має з собою радіо, she points it to the earth, she sends a signal. Ігоре, я приїхала, все в порядку. Okay? Now, тому що вона не рухається, і він не рухається, їй здається, що то бере 10 років, щоб той сигнал полетів на земську кулю. Йому також то здається. Okay? So для неї то є 10 років пізніше. Вона вже збудувала собі хату, вона вже там живе 10 років. Він вже чекає 20 років від того дня, що вона відлетіла, і тоді, і тільки тоді він дістає від неї той сигнал «Я приїхала». Okay? І він, і вона, вони ходяться, що то буде 10 років, because they're not moving. Now, він то чує, і на другий день він відразу їй пускає сигнал, і він їй каже, вернися, я за тобою тужу ще. То вже задовго. І вона каже, окей. І вона тоді, перепрошую, то також бере 10 років. Okay? Because it's 10 light years away, and light, radio waves travel at the speed of light, то бере 10 років, щоб той сигнал вернувся. So at this point, він вже чекає 30 років, а вона чекає 20 років. І тоді вона каже, окей, я вже маю досить з тою планетою, я сиджу в ракету і вертаюся. She comes back at the same speed, at nearly the speed of light. Їй здається, що той подорож, то брало півдня, а йому здається, що то бере ще 10 років. So, як вона вертається, вона є 20 років старша. Most of that time was spent on the planet. Almost all 20 years were spent on the planet. Вона там тільки була, я перепрошую, так, 20 років на планеті, а тільки один день in transit, а йому здається, що то брало 40 років, 10 років, щоб вона там полетіла, 10 років, щоб сигнал вернувся до нього, 10 років, щоб його сигнал полетіло до неї, і тоді 10 років для неї вернутися. Each one of the trips took 10 years, according to him.
Тому якщо їм було 30 лет, і потім вона полетіла, вона прилетить обратно, йому буде 70, а їй ще буде 30. Так?
Так.
Mm.
Він багато старший від неї тепер. That's exactly right. Now, that sounds crazy, okay? Але this actually happens. І ми знаємо, що це бувається. This is not some crazy kind of made up science fiction. Okay, як ми це знаємо? I'm going to give you two pieces of evidence, як це працює. Перша річ, атомові годинники на літаках. So in 1971, the US Naval Observatory took 3 atomic clocks. Okay? Це є знімка одного з тих годинників. Okay? They really did this. They took 3 atomic clocks, which were synchronized very, very precisely, один до другого, чи один до другого до третього. 2 of them were put on airplanes, and 1 was kept on the ground. 1 airplane went east, 1 airplane went west, і довкола світу, and they came back and they compared the clocks. Okay, the theory, значить, що the equations, я вже вам показав what that equation looks like. The equation said that the eastward plane should lose 40 nanoseconds. So a nanosecond is a thousandth of a millionth of a second. Okay? So 40 nanoseconds should be lost going east. And according to the equations, 275 nanoseconds should be gained going west. The test results on the bottom show 59 seconds were lost going east, 273 seconds were gained going west. That's pretty close. Okay. Now there's a lot of experimental error there, okay, because the planes are accelerating, they're going up, they're going down. There's lots that they have to take into account. Okay. They've done this experiment since then many times, and it comes out closer and closer every time with better and better instruments. Okay. It is just about exactly where Einstein said it should be. Now, ще один приклад. Muons. Можна думати, muons are subatomic particles. You can think of them as fat electrons. They're electrons, but they're more massive. Okay? Now, muons are created when the solar wind hits the upper atmosphere. Okay? So they literally come out of nuclear collisions. They are created in jets up there, about 10 kilometers higher than the surface of the Earth. Okay? Muons have a half-life. To znaczy, że they decay. Their half-life is about 2 microseconds. That's a millionth of a second. So in 2 millionths of a second, if you start with 100 muons, 2 millionths of a second later, you have 50. If you wait another 2 millionths of a second, you have 25. Okay, so the number of them gets cut in half every 2 millionths of a second. So they disappear pretty quickly. Okay? But they're moving very fast. They're moving at 99.99% the speed of light. Z neba na zemlю. The distance is 10 kilometers. Okay? Na жаль, there's not enough time for them to reach the Earth even at that speed. Okay? According to classical equations, значит that speed is distance divided by time. Okay? The distance that they have to travel, the distance that they can travel in one half-life is about half a kilometer. So going 10 kilometers, you're going to reduce the number of them drastically. In other words, 17 of their half-lives to go from 10 kilometers up to the surface of the Earth. The fraction of them that would remain is 0.0007%. So we wouldn't detect any. Right? There would be very, very few touching the Earth. Ale, fakti extra, we see a massive number of muons hitting the surface of the Earth. They are detected regularly. Jak це може бути? And it fits the equations of relativity almost perfectly. Time dilation, so для них, бо вони так швидко їздять, летять, time slows down for them. At 99.99% the speed of light, they're actually only experiencing a quarter of a half-life in the time that it takes to go from up there to down here, a quarter of a half-life. Instead of 17 half-lives, they're experiencing a quarter of a half-life. Okay? But для них, time is slowed down so much. Another thing that happens, lengths get shorter. For them, it does not look like it's 10 kilometers from them to the surface of the earth. It actually looks like it's 0.14 kilometers, okay? 140 meters. To дійсно дуже коротке. The fraction of them that reach the surface of the earth is 85%. Okay? So both of these are direct tests of the slowing down of time. Okay? І то дійсно буває. Now, can you ever get to the speed of light? Right? Бо я вже вияснив, що тим ближче ми приходимо, тим більше цей ефект. Але can we get there? Can we ever get to the speed of light? The simple answer is no, it cannot be done. You can get close. You can get arbitrarily close. You can never get there. І причина є that third effect, the mass increases. So я вже вам сказав, that's what the equation looks like mathematically. Here's what it looks like on a graph. So on the bottom axis, that is how fast you're moving in units of the speed of light. One, and as you can see, the curve of how much time slows down, how much length contracts, and how much mass increases really takes off as you come closer and closer to that speed of light. The closer you get, the bigger the number gets. Now, two very simple physics equations, Shravshiv Chacha in the first year of physics, the force that you have to apply to something to get it to accelerate is proportional to the mass. So if you want to accelerate something, if you want to speed something up, the amount of force you have to apply to it, the more mass you have, the more force you have to apply. So najal, tim skorshe shtrotilitish, the bigger your mass, and if you want to go even faster, you have to apply a bigger force. But when you do that and you do go faster, now your mass is increased, and now you got to apply even a bigger force. And you actually have to apply an infinite force to get to the speed of light. Kinetic energy is 1/2 the mass times the speed squared. Same thing. The bigger your mass, the more energy you have to apply to get to that speed. So in reality, you can never get to the speed of light itself. Okay, that's special relativity, and moving fast. General relativity is all about gravity, and it also slows down time. So Klasichne, Isaac Newton's image of space is straight, it's flat. Space is flat, right? This is how we all think about it. Einstein said, actually not so much. Space is curved, and gravity is what causes the curvature. So Tony Yeshtra sunset because of a force going around in a flat space. Actually, sunset curves the space around it, and Earth is moving in a straight line in a curved space. Earth is moving in a curve, but it's not. It's moving in a straight line in the curved space. Space is so curved, light follows the curvature as well, because it's moving in a straight line through the space. If the gravity is big enough, the curvature can be so big that light will be caught in orbit around the object. That's what a black hole is, because light can't even escape, because the space around it is so curved that light gets trapped. Okay? Now, time slows down in a gravitational field. Tim bilshe, the gravity attraction, the more the curvature of that space-time, the more time slows down. And light is bent. In fact, Newton predicted that light would be bent. Einstein predicts it's bent about twice as much as Newton said. Ale najważniejsza rzecz dla nas jest, że czas zmieniaється, czas powolisze переходить. Okay, real life example of general relativity. Моє улюблене місто. Одне з моїх улюблених міст. Якщо ти сидиш in the Hudson River, супроти когось, хто сидить at the top of a skyscraper, this is obviously an old picture, time moves slower on the ground than it does in a skyscraper. So, якщо ти живеш in a penthouse apartment, time is actually moving faster for you. And if you're on the ground floor, time is moving slower. So you live a little bit longer on the bottom. Now, how much longer? Okay. Now, Zemshki Kuli, it's a very, very small effect. This is Mount Everest. Somebody experiencing time at the top of Mount Everest versus sea level. In all of the time since Earth's formation, 4.5 billion years ago, the cumulative difference between sitting on the top of Mount Everest, which didn't even exist 4.5 billion years ago, but let's just pretend it did, the difference in time between being there and being on the ground is 39 hours over a stretch of 4.5 billion years. Okay? It's a minuscule effect. Tut na zemski kuli. Якщо хтось бачив the movie Interstellar, they incorporated general relativity principles in the movie. I dosyć dobre. They had good science consultants help them out with this. 1 hour near a black hole was equivalent to about 7 years on Earth. And it depends on the mass of the black hole. That's a realistic experience. Okay, tests of general relativity. Jak my знаємо, що це буває? Перша річ, як Einstein це написав, and he did this in 1915, so 105 років тому. One of the problems that existed, that they didn't understand, was something called the precession of Mercury's orbit. So Mercury's orbit is not a perfect circle, and the orientation of its ellipse changes with each rotation around the sun. So the orbit itself is moving, if you will. І вони не розуміли чому. Einstein, his formulas predict the precession of that orbit beautifully, very, very accurately. Okay. Але two important tests. Тому він то написав під час Першої світової війни. І та війна, it stopped the test because they needed an eclipse to see the bending of light. So під час затміння сонця, during an eclipse, you can actually see the stars very close to the sun. So if the light from that star comes close enough to the sun and the sun bends it, it will make the star appear to be in a different position than it actually is. Because we see it without the sun, and now we see it the light from it being bent by the sun. Now, Newton's formulas were off by a factor of 2, and Einstein nailed this. So this was the first important conclusion, important test showing that general relativity was true. More recently, LIGO, a massively complex gravity wave detector, actually measured 2 black holes merging together. Okay? Now, these 2 black holes, they're 1.3 billion light years away from Earth. The amount of energy put out, the amount of power put out in the 0.2 seconds, the last 0.2 seconds of their collision was 50 times as powerful as all the light from all the stars in the entire observable universe. Okay? Massive amounts of energy being put out in all directions, and 1.3 billion years later, we detected it. Okay? Since then, they've detected merging neutron stars, which have a smaller effect because they're not as massive as black holes. And they have completely opened up a new area of astronomy in gravitational waves. Tak samo takie light waves, optical, that we can see using telescopes, allowed us to see the universe in completely new ways. Compared with these gravity waves, with the gravity waves detectors, we can measure things completely in a completely new way, all because of general relativity. Now, I'm going to bring it all together. Special and general relativity, and talk about GPS satellites. This is a genuine scientific study of the effects of time dilation. Okay, so what we're measuring here, how far away are you from Earth's center? Okay, so in kilometers, the purple line is the surface of the Earth. So mifshi tam sidama. Okay, we are sitting where the green line hits the x-axis. And then the y-axis is the number of picoseconds that are gained or lost for every second here on Earth. Okay? A picosecond is 1/1,000,000th of a second. Okay, so very, very small differences. Now, because GPS satellites, they actually orbit about 20,000 kilometers above Earth's surface. It doesn't change, so two things are happening to them. One, they're moving very fast, so time slows down for them as they're flying. Two, they are farther away from Earth, so there's less gravity there. So time slows down for us compared to them. So time goes faster for them because of gravity, and it goes slower for them because of their speed. Okay? And those two effects are in the red and the green. So the first one down here, the orbital slowdown, they lose about 100 picoseconds every second that we experience because they're moving so fast. But they gain about almost 500 picoseconds because they have less gravity. In other words, we lose almost 500 seconds compared to them. The net effect is that they lose about 360 picoseconds every second that we experience. Okay, who cares? These are such small numbers. Well, you care. I care. Chumu, because GPS wouldn't work if you didn't correct for this. What do I mean? So these numbers, right, we're talking about 0.35 nanoseconds, 350 picoseconds, or less than a nanosecond. But the speed of light is about 30 centimeters every nanosecond. So if you multiply that out, it actually comes out to about 10 centimeters. If you don't correct for this, the GPS satellite is going to tell you that you are 10 centimeters farther from where you think you are every second. So over the course of an entire day, the GPS would be in error by about 3 football fields in length every day, cumulative. So if we didn't correct for this, GPS satellites would never work. Okay? So that's another way to think about Chumutoya Vajne, and that it actually is true. Both of these effects are true. Time is slowing down and time is speeding up depending on gravity and speed. Now, how does this affect time travel? Well, hopefully you have figured it out. If you move very, very fast, actually, the duże szybko idziesz, time slows down for you. Innymi słowami, Halia basically went to the future. She zipped around for a day or two, and she comes back, and Ehud is much older. That's going to the future. Okay? Tosame with gravity. If you orbit a black hole or go to other places where there's a lot of gravity, time slows down for you. So, innymi słowami, you're going to the future. So, it's very possible to time travel to the future. The problem is there's no way to get back. So, time travel does exist. Bez pytania, absolutno tak. Muons do it all the time. Right now they're doing it. Okay? Anything in orbit is doing it, or we actually are doing. We're slowing down compared to them. So it's happening regularly. There's no way to go in the other direction. Okay. If anyone isn't completely confused at this point, bo ja znаю pierwszy raz ja nauczył się, this was just so bizarre, this can't be true. Ale ja bym rozказał, jak ja był studentem, ja musiał mierzyć. I had to measure the mass of electrons as they were zipping around as a function of the speed of light. And when I saw them line up with the relativity equations, it was amazing. It was like, wow, this is actually true. It's crazy, but it's true. Okay, czy є які-небудь питання?
So я маю.
Прошу.
Я цей video стягну. So, because it takes so much energy to get up to light speed, you can't get up there. However, all electromagnetic energy is at light speed.
Tak.
So that implies no mass.
In fact, no mass. There are some theories that say that if something has no mass, it must travel at the speed of light. Massless things can travel at the speed of light, but if you have mass, you cannot travel at the speed of light.
And one of the ideas about propulsion in outer space is to use, what is it, protons, or to use reflection of electromagnetic energy to accelerate to near the speed of light.
So, Tak, the idea is you create essentially a solar sail, a massive, very, very light, a very large area trap for photons, for electromagnetic energy from the sun, and it pushes you. You use the momentum of the photons to accelerate, and you've got a constant acceleration. No, it's not constant, because the farther you go away from the sun, the less flux you have of that energy hitting your sail. So the acceleration slows down, but your speed doesn't slow down. You can go actually pretty fast. Idea a flyby. So they think they can get things to, if it's light enough, they can get things to close enough to the speed of light. It'll reduce the speed. It'll reduce the trip to Alpha Centauri from 4 years. Well, 4 years at light speed. It'll take something 40 years to get there. It's so about the 10th the speed of light is about as fast as they think they can get something going. Apparate on the contraption. So they can make a very, very, very light apparat and send it there, and then send the signal back. We could actually take pictures of the planet, of a flyby of planets. Now, that sounds crazy, but the engineers are working on that as a realistic way to do it. The thing is, once you get up to that speed, there is no way to slow down. So those cameras will just zip right by the planet at a 10th the speed of light, and keep going. And there's really no way to stop them.
So couldn't you find a little black hole to bend their path and send them back?
Sure. But it'll take another 50 million years to get to the black hole.
So if
For us.
if electromagnetic energy has no mass, does the sun lose mass?
Yes, because I didn't go into this part of Einstein stuff, but energy equals mass times the speed of light squared. So yes, it converts mass into energy. It is losing mass.
Okay. Дякую.
Прошу дуже. Okay, ja wam obiecał links to the Nova special and to you know what I'll do? Я wyślę e-pocztą.
Я маю питання.
Прошу.
Is it possible for someone to control time? Not like hand, like so, like on a computer or something like that. Is it possible?
To control time. Well, the control that you have is by manipulating your speed. So you can control how fast time changes for you by going faster. If you go fast enough, you will slow time down in a very specific way, in a very precise way. So, but that's the only, that and if you are in a gravitational field. So go to a black hole or go near the speed of light, neither of which is easy to do.
Дякую.
Прошу. Okay, so є питання, why can't we breathe in space if there is oxygen? То дуже добре питання. There is no oxygen in space. Тому ми не можемо там дихати. Але I will say that the Perseverance rover has a device on it that hopefully will convert the carbon dioxide. So the Martian atmosphere is about 1% as thick as our atmosphere. So it's very, very thin atmosphere. And it's made mostly of carbon dioxide. So tiki instrument on the rover, which will pull the carbon dioxide in, and using heat and using electricity, it'll break it into carbon monoxide and an oxygen atom. And it'll do that to another carbon dioxide. So it'll break into carbon monoxide and an oxygen atom. And the two oxygen atoms will fuse to create oxygen molecule. So it's going to convert carbon dioxide into oxygen and carbon monoxide. And if it can do that, then they might be able to manufacture oxygen molecules on Mars out of the Martian atmosphere. То є важне не тільки, що ми дихали, але важніше to actually create oxygen, which can be both a fuel and is necessary for combustion for the astronauts to come home. Окей. Чи є які-небудь інші питання? Бо то вже по 4 годині тут on the East Coast, і то значить, що то вже 11 в Львові. So час або спати, або на напиток.
Я маю, sorry.
Іди вперед.
Окей. Моє питання є про час. So ти сказав, що час не відбувається для ті photons, the light particles that travel at the speed of light, right? Time doesn't happen, it's irrelevant. Тоді чому для нас, for humans and anything else occurring in the world, why is time important? And how does time work? Because there's a lot of questions with, is time an illusion? How do we come up with time? Does it really exist? And there are a lot of questions surrounding that. So why is time so important to us if for photons, it doesn't matter at all? Is it just us trying to, is it something that we came up with for humans to think of? Is it a construct of our mentality, our understanding, or limited understanding? Why?
It does not appear to be a construct of ours. It appears to be part of the same way that distance is not a construct of ours. So we live in 11 dimensions, 4 of which are large that we can observe. And 3 of those 4 are spatial, distance, right? Forward, backward, left, right, up, down. One of those is in the same units, in units of meters, is the speed of light times time, but it's also multiplied by I, the imaginary number. It's not a physical dimension that we can traverse in the same way that we traverse space. But it is part of, it's why it's not called space anymore, it's called space-time, because time is woven into the fabric of space. It is very similar to space. But like space, it came out of the Big Bang. So when people ask what happened before the Big Bang, most people don't realize that what they're asking is like, how far away is nowhere? It's like, it just, the question doesn't make sense. Time didn't exist before the Big Bang, so there couldn't be anything before it because there was no time then. So no, time is not a figment of our imagination. It doesn't traverse for photons. Photons experience no time. Nothing that travels at the speed of light experiences no time. In fact, so Einstein's equations don't forbid something from going faster than the speed of light. What they forbid is anything with mass from going through the speed of light. But if there are particles that already exist with mass already moving faster than the speed of light, then for them, they can never move slower than the speed of light because they will encounter the same increase in mass as they slow down. So, and in fact, for them, if they exist, time is flowing in the other direction. So no, I don't think it's a figment of human construct or limited thinking. But that got very deep very quickly. Я перепрошую. Okay, this one's recorded, so я пішлю, якщо хтось хоче далі, або if you have amnesia, not amnesia, insomnia, я задовго говорю. If you have insomnia, go listen to it again. Я вам бажаю доброго дня і приємного вікенду. Скоб, до побачення.
Дуже дякую, Скоб.
Дякуємо.
Дякуємо.
До побачення.